Okay, so in this video, we're going to start work on question number E. How do you interpret the coefficient for GPA in the logistic regression result? So for the logistic regression result, the coefficient for GPA is 1.4918. So how can we interpret it? So in the lecture video and also your textbook, I emphasize that you cannot say, hey, if GPA increased by 1, the probability increased by 1.49. It is totally incorrect. The main reason is that our logistic regression model is look like this. It's non-linear. So anything one level increase is no longer about, hey, how much that is measure how much it change. Instead, it's actually measure the odds. Okay, so now therefore, what is the right way to interpreting this 1.4918? So the first thing you need to do is convert this 1.4918 to the odds. Okay, so first of all, the way we are converting the GPA to odds is using the exponential of your coefficient. Okay, exponential to the coefficient. Okay, A, B, C, D, E. So step 1. Getting the odds. So the odds will equal to exp exponential of this. Okay, so that is the odds related to the GPA. But that's not how we're interpreting that. Okay, so in order to interpreting this 4.33, this 1.491, we need to apply for this formula. Basically, use the exponential, what you just converted, and the minus 1. Step 2. So that will give you this value, minus 1. Okay, so that is how you interpreting the GPA. First of all, it's a positive. When you see any coefficient positive, that means if that factor increase, given the other one doesn't change, that will increasing the probability of your outcome you are looking for. However, in order to quantify that changes, that's you need to do the 2 steps. First, convert the coefficient to the odds, and then using that, taking the exponential and then minus 1. So the way we're interpreting this 3.44 is that if the GPA increase by 1, the odds of a candidate passing the exam will increase by 344% given the year of experience the same. Okay, as you can see here, very similar as we interpreted before. However, we emphasize this is about odds, right? The second is instead of directly using the coefficient value, we actually did some transformation. We first take exponential of my coefficient and then minus 1 to reflecting the changes. Okay, so therefore, this is I mentioned it in the lecture, I also mentioned in your textbook. So if you don't know why we are using this formula, please read the book or watch the optional lecture to understand why we need to use exponential b minus 1 here. Okay, so times the 100 because we want to convert it to 100. Okay, I forgot here. Maybe I should do this way. Again, we just try to convert to percentage. So therefore, I got this 344%, 344%. That is how you should interpret the partial coefficient, interpret the coefficient from the logistic regression model. Okay.